girl, how's biochem going?
Hey, it really sucks, but we did something cool last week.
Oh really? What was it?
We expressed a protein in E. coli, but there are other proteins in the mixture, so I'm not really sure how to separate it from them.
Is it tagged with something?
Yeah, I think it's tagged with GST.
Awesome, I have an idea of how we can purify it. I'll show you.
Oh, perfect.
I'll teach you how to do it, but first you have to do the purification dance.
So will you teach me purification now?
Yes.
Yes!
Okay, so you're gonna take your solution and containing your protein and mix it with some agarose beads coated in glutathione. Then the GST is attracted to the glutathione, so the GST tagged RB is attached to the beads. This leaves behind all the other proteins that aren't our proteins of interest. Then you will wash the beads to ensure that all the unwanted proteins aren't connected to it anymore. After the washing of the beads, you'll add diluted glutathione to the mixture in order to reverse the reaction. This leaves behind your purified GST RB protein. Does that make sense?
Not really.
Okay, let me break it down for you.
As KK mentioned, the protein of interest, RB, is tagged with GST, or glutathione S-transferase. Glutathione S-transferase has a strong binding affinity for glutathione. Because of this, agarose beads will be soaked in glutathione. Then we will combine the glutathione beads with our protein solution containing our GST RB proteins. Now it gets fun. Here's where the glutathione beads will attach to the GST RB proteins, kind of like this. As you can see, all the gray GST tagged proteins have attached to their respective glutathione bead. After this, the beads will go through a series of washes to ensure that only GST RB proteins are in the solution. Now you may be wondering, how do we get these beads away from our protein in order to use our protein? Well, good news, the binding can be reversed. All you have to do is add reduced glutathione to the solution in order to detach the beads from the GST RB proteins. It works a lot like this. As you can see, your final result will be your GST RB proteins purified in the gray, separated from your glutathione beads, which are represented by the green. Hey guys, so since you just got done purifying with Michelle, I'm going to walk you through concentration. When we're trying to concentrate our protein that we just purified, we're going to use a centricone filtering unit. Here's a variety of centricone filtering units, and they're based on different sizes. So we have 5 sizes: 3K, 10K, 30K, 50K, and 100K. And basically the sizes tell you what the molecular membrane weight limit is for that filtering unit. So 3K would be 3 kDa weight limit. 100K would be 100 kDa weight limit. Now, centricone filtering units are built with a vertical membrane design and a true dead stop, which allow the proteins that you're trying to concentrate to get stopped in your filtering unit. So now that we have our purified protein, we're going to put our purified protein solution in our centricone filtering unit. So we're going to pour it in, as you can see in the red, and then we're going to cap it and we're going to put it through the centrifuge. Now, when we centrifuge it, it's going to allow everything that's not the protein to get pushed to the bottom. So whatever your buffer is or whatever solution your protein is in, that's going to be found down here. And your your protein is going to be found in your filtering unit, which is the membrane. That's your weight limit. So whatever your protein of interest is that you're trying to concentrate, is going to be stuck here in your filtering unit based on the size you pick. So let's say this is 100K. Whatever is less than 100K will be found in your filtering unit. Then, if you want to conduct a buffer exchange, you would add however much of your buffer, your exchange buffer, into your filtering unit, and you would centrifuge once again. So then this would be the excess of your exchange buffer, which you don't want. You would just get rid of this, and that would leave you with all your proteins that are now desalted and have gone through buffer exchange and are concentrated. So you may be asking yourself, why do we want to purify protein? Well, I'll tell you. Reason number one, in order to study a specific protein, you need to be able to purify that protein and make sure you're only looking at that specific protein. So for our example, KK was looking at RB specifically, but she had to purify it in order to see exactly what RB did. Reason number two, we want to understand the structure of the protein. In order to understand the structure of the protein, we need the protein to be by itself. Reason number three, we want to be able to characterize protein function. Now, every bio major knows that structure equals function. So if we understand the structure of our protein, by purifying it, we're able to characterize the protein function. Reason number four, once we know the structure and the function of the protein because we have purified it, we can understand its interaction with other proteins. Reason number five, in order to present any novel ideas for target-based drug therapy or any sort of research ideas based on a specific protein, you need to be sure that you're able to purify that protein to back up your ideas. And if you're presenting information on a solution that contains a protein but may have other proteins, then your evidence isn't going to be fully supported because the evidence may be contributed to a different protein and not the one you thought you were looking at. So we have to purify in order to have some credibility and to further understand the structure of the proteins we're looking at.
What did I say?
Wait, what?
I'll teach you how to do it, but first you have to do the purification dance.
Stop. Okay. Bailey, I need you to help me with the purification dance. I don't know how to do it.
Okay.
Okay, teach me. So it's like this?
Yeah.
But like, I don't understand. Like, how do you move your arms that way?
Musical chairs.
Go! Run out! You guys are so cute. Okay, now all the greens are gonna disband these people.
What does that mean?
Push them away.
Break them apart!
Get away! Get out of here!
Now the greens line up over there. I mean the grays, the grays, the grays.
All of us.
All the grays!
Hold.
Great job, guys.
Okay,
But like less awkward.
so like, this is awkward.
Yeah.